So in this video we're going to be talking about pressure and the different factors that affect it and how it acts in solids, liquids and gases. But one thing that you want to think about, because you've all got quite a naturally good understanding of pressure and experiencing pressure from different things, we're just going to learn how to quantify it mathematically, is would you rather have an elephant stand on your foot or a rugby player in high heels? Which do you think would hurt more? Because which would be exerting the biggest pressure on your foot? So let's have a little look at the equations we can use to quantify the size of pressure. So when we look at solids, we can, and other situations as well, but mainly solids, we can use this equation here. Pressure equals force times area. And we're going to measure the force in newtons as normal. We're going to measure the area in meters squared. And so that gives us pressure in newtons per metre squared. Now, if you've measured the pressure in newtons per metre squared, you could also call that a Pascal, or PA for short. So we need to practice rearranging this equation, so let's have a go at that now. You can press the pause button and then check your answers. If we rearrange the equations, we get force is equal to pressure divided by area, and we get area is equal to pressure divided by force. Check that you're confident to rearrange those equations just as you would do in maths, and then we're ready to move on. So if we're going to measure the pressure exerted by an object on another object, we need to measure two things. We need to measure the force that one object applies on another, and we need to measure the area, the contact area between those two objects. To measure the force, quite often, the force is going to be the weight of an object. And we can use the equation weight equals mass times gravitational field strength. So really important to remember that mass is measured in kilograms. Gravitational field strength can be measured in newtons per kilogram, and weight is measured in newtons. So if you've got a mass, you can turn that into a weight using weight equals mass times gravitational field strength. And on Earth, the gravitational field strength is always going to be equal to 10. Now we could use a Newton meter to measure the force that something applies on another one, because a Newton meter is a piece of equipment that measures the force applied on something. To measure the area, we're going to use a ruler or we're going to use graph paper, and then we're going to put them all into the equation pressure equals force over area. So let's have a go at a question. This is a question from the revision questions on the revision website. There are lots of other questions to have a go at once you're happy with this one. So the weight of a buggy is 40 newtons on Mars, and when the buggy landed on Mars, it rested on an area of 0.025 meters squared. Calculate the pressure exerted on the buggy. So first of all, I need to write down the things that I know and the things that I don't know, and check they're in the right units. This is in newtons, so that's fine, and this is in meters squared, so that's fine. So next, I'm going to write out the equation that I'm going to use. So I'm going to say pressure equals force divided by area, and I'm going to put my numbers in, so 40 divided by 0.025, and that is going to be equal to something. Let's calculate that now. That is equal to 1600 newtons per metre squared. Right, here's another question. This question is about a wood chopper. So somebody holds a 5 kilogram mass here, and then it falls down on a smooth rod, and then there's a blade on top of the wood, and it chops the wood. So let's have a look at this part of the question. The diagram below shows two different blades, A and B. The formula for pressure is pressure equals force over area. Which blade puts more pressure on the log? Write the letter. Explain your answer in terms of area. Use the formula to help you. So let's use the clues that they've given us in the question. They want the answer in terms of area, they want us to explain our answer, and they want us to use the formula. So here's the formula. So in terms of area, which blade is exerting a force over the biggest or smallest area? So hopefully you can see that if this part of A is in contact with the wood, that's a much smaller area than this part here of B. So we're going to use our fact so method because it's an explanation question, and we're going to do the fact in terms of area and the formula, and then we're going to say so something happens with the blade. So let's give that a go now. So for the fact we can say pressure equals force divided by area. So the smaller the area, the bigger the pressure. So that's one fact so, but we want to be doing on average 2 fact so's per explanation. So let's do another one. So now we have a look at A and B and we look at which one's got the smallest area and the biggest area. So then we can do another fact and we can say blade A has the smallest area, so exerts the biggest pressure. And the answer is A. A puts more pressure on the log because it has a smaller area. Now, pressure can also act in liquids and gases. So a word that we use to describe a liquid and a gas is a fluid. So let's have a look at pressure in liquids. So first of all, liquids exert pressures in all directions. So if I take a point in this liquid here, there is an equal pressure acting in all directions away from that point. But if I go deeper into the liquid, so if I move that point from there to there, I still have an equal pressure acting in all directions from this point here, but the pressure in here at this point is not the same as the pressure there in that point. The deeper in the liquid you are, the greater the pressure. So the pressure here is bigger than the pressure here because there is a greater weight of liquid above this point compared to this point, pushing down on that point. So that means if we have a look at a measuring cylinder and we put different holes in it and we see how far the water pours out, how far it goes, the higher the pressure, the further the water will travel before it hits the ground. So up here we've got low pressure, so it doesn't travel very far. Here we've got medium pressure, so it travels a bit further. And here we've got really high pressure, so the water is squeezed out really quickly and travels really far. Now pressure also acts in gases. You can't recognise it because you're so used to it, but actually there is a pressure pushing down on us right now because of the mass of the atmosphere above us. And if that mass changed somehow, we would experience a different pressure. So if we go to the top of a very tall mountain, we experience a different pressure because there is less force from the atmosphere above us than there is if we are down at sea level. And you can see this in really interesting things. So for example, you can boil liquids. So you can boil water if you're a mountaineer. You can boil water at a lower temperature on the top of a mountain than you can down here, which is quite fun. Right, so that's pressure. Hope that's been helpful. Try the revision questions on the website. If you have any questions, let me know.